Hello and welcome to my video. Here I want to explain to you about how ransomware works. You know, those viruses that infected your computer and making all or some of your important file can be opened except you send them some money. So in exchange they will give you a key or password or anything together with sometimes a certain software, so all of your file can be returned to normal. Okay, first, so how can any computer can be infected by ransomware? Okay, basically any program or software will not run if you don't execute them, obviously. So it's like, so what might happen is either you has been tricked by the other party. So it's like when you click a strong link, or in the download pack you just click the wrong link. So when you download it and you install it, and boom, you just install the ransomware, and now you can access all or some of your file. Or the other party has abused the vulnerability of the system of your computer that can make that party have been an access to run the malicious software. And this malicious software, of course, in this case is ransomware. And to prevent this, for the first case, you can avoid by never click an unknown link or strong link. And for the second case, I think you need to update your system to the newest, with the hope that in the newest system or newest update, those vulnerability already has been fixed. Okay, what I exactly want to talk about in this video is what exactly that ransomware software do in your computer. Simple, it's just encrypting all of your file. So what is encryption? It's changing the binary content of your file so your computer or anyone can understand that file. This is why you can access or execute that file. For example, if you have a Word file that already been encrypted, and when your computer want to execute it using, for example, Microsoft Word, it can, because its file not resemble a Word file anymore. So that's why you can access or open your file when it infected by ransomware. For some encryption algorithm, the encryption process will follow a key or some password. Other than that, this key file is a key to revert all of your encrypted file to normal. The act of revert the encrypted file to normal is called decryption. Okay, after this, I want to make you more understand with the theory I talked about here previously. So I will show you some piece of code to demonstrate of how this ransomware work. So here we have 3 scripts and 1 key file, and here a PDF, doc file, PNG, and MP4 file. This file we will be encrypt it using this script, and decrypt it again using this. The key will be generated using this, and let's see. I will encrypt it first, and look, all change. This is what happened when your computer infected by ransomware, and let's access it. Oh, looks like it's not a PDF file anymore, it's just a just a string, lump of string. And previously I say that when you attacked by ransomware, you can access the file, but here I can access it. But this is meaningless because this is not the real content of this file. Originally this is a PDF file and this is originally a PNG file, but right now it's just some string. It's meaningless. So now let's just decrypt it. Oh yeah, first when we encrypt this file, we use this generated key here, and when we want to decrypt it again, we use the same key. Later I will show you the code so it all will be clear. And when I access this, here I decrypt, all the file come back to normal. PDF file, the PNG, this is just a video, and our doc file is come back. Now I will show you the algorithm. First, when we want to encrypt this file, all of this file, when we want to encrypt it, we must generate a key. So here the algorithm, I will generate a key and write the key in the file key.key. Here the cryptography algorithm that I am using here is a fairnet. Actually there are many cryptography algorithm or encryption algorithm you can use, but for this case I am use this. And this is the encryption script. So first I already list all the file that I want to encrypt. There are PDF file, doc, docx, png, jpeg, mp4, etc. And in here I list all of PDF, doc, docx file in one array. And then second is I opening the key. This is key file, and then I'm using the generated key that I read it here. And second is I iterated all the file that I collected here. First I open the original file, I encrypt it, I encrypt the data, and second is I remove the original file and write the new file as the encrypted version. In the encrypted version there is a suffix .locket here. This is the process of encryption that I'm using here. And for the decrypt, it's more simple. First I collect all the file with suffix .locket. Here I'm using as a mark for if that file is encrypted. And first I opening the key using the key, and then I iterate all the encrypted file that I already collected here. First I open them and decrypt the data, remove the encrypted version and write the decrypted version. The decrypted version is the same as the original version. So that happened. Okay, now I want to test. What if I encrypt all of this file, and in the key file, let's say I change just one character. This is 2D, and let's decrypt it. Now it's error because the key is not the same we use when we encrypt it. So when we want to encrypt and decrypt the file, the key must be same. Let's revert back to normal and let's decrypt it, and it's success. This is same as ransomware. So when the key of you input to the software is wrong, it will not revert back to normal. It's same like this. But I think in the real case of ransomware, I think they will not use a Python script, because if they use like this script, this is so obvious. The algorithm is obvious to the victim, so it's not effective attack. And then I think if this real ransomware, I think when the key is wrong, the user will not know, but in this case we know. I think this is a weakness for the ransomware if they use fairnet, because you can use brute force to find the real key. I think that's all. I hope you understand my explanation, and the code and all this file, I think, yeah, I give it in the description of this video. Thank you.